Hello everybody. So in this lecture, we are going to start our second unit, methods of separation. Okay. So in SEM-VI we have studied paper chromatography and thin layer chromatography. Here we are going to learn gas chromatography and HPLC technique. Okay. We'll see. Okay. So remember here, in the chromatography, there are two phases. One is a stationary phase, or there is a mobile phase. So whatever components or the components from the sample which we are going to separate or which we are expecting to separate, that will be supported on the solid, and their separation will be carried out by the mobile phase. Separation will be carried out by mobile phase. So as we know that there is a stationary phase. So stationary phase may be solid, may be liquid, but mobile phase either liquid or the gas, either liquid or gas. So here in this topic, we are going to focus for gas solid and gas liquid chromatography. Gas solid and gas liquid chromatography. Okay, so gas is a carrier of the component. Okay, and solid or liquid are the supporter of the component. So in this way, we are going to study all the topic. Okay, so if the stationary phase is a solid, then there is adsorption. If a stationary phase is a liquid, then there is a differential solubility. Thus, the mechanism of separation in the gas solid chromatography will be differential adsorption. Okay, and in gas liquid chromatography, the mechanism of separation will be the differential solubility. लिक्विड आहे म्हणजे त्याच्यामध्ये दुसरे कंपोनंट सोल्युबल असणार आहे. है ना, स्टेशनरी फेज लिक्विड असणार आहे म्हणजे बाकीचे कंपोनंट काय असणार त्याच्यात सोल्युबल असणार आहे. मात्र जर स्टेशनरी फेज हा सॉलिड असेल तर बाकीचे कंपोनंट त्याच्यावरती काय होतील, ऍडसॉर्ब होतील. म्हणून तिथे ऍडसॉर्प्शन आहे, डिफरन्शियल ऍडसॉर्प्शन, डिफरन्शियल सोल्युबिलिटी. आता डिफरन्शियल वर्ड का यूज केला, याचं कारण असं की सगळेच्या सगळे कंपोनंट जे आहे एखाद्या सॅम्पल मधून ते एकाच ठिकाणी ऍडसॉर्ब नाही होणार. ते त्यांचं जे बाइंडिंग कॅपॅसिटी आहे टू द स्टेशनरी फेज ही वेगवेगळी आहे. समजा ए बी सी तीन कंपोनंट हे एकाच सॅम्पल मध्ये आहेत, तर तीनही कंपोनंटचे केमिकल प्रॉपर्टीज सेम नसणार आहे. ऍज दे हॅव डिफरंट केमिकल प्रॉपर्टीज, देअर बाइंडिंग कॅपॅसिटी इज ऑल्सो डिफरंट, राईट. आणि म्हणून ते त्या ठिकाणी काय होणार आहे, स्टेशनरी फेजला वेगवेगळ्या ठिकाणी किंवा वेगवेगळ्या पोझिशनला जाऊन त्या ठिकाणी ऍडसॉर्ब होतील. and they can be separated. Okay, so how we can define here distribution coefficient. Okay, so what is distribution coefficient? Distribution coefficient, see, it is a ratio of concentration of solid in a stationary phase to the concentration of solid in mobile phase. Concentration in stationary phase to the concentration in mobile phase. Okay, so smaller the value of K indicates more and more components are going with the denominator, means they are going with the mobile phase. Okay, they have more affinity for the mobile phase and less affinity for stationary phase. If higher value of the K is there, then what that indicates that the components are having more affinity towards the stationary phase and less affinity towards mobile phase. Okay, if but the problem is here, if that component is very strongly attached with the stationary phase, then it's a separation, or to take that component out of the column, it's very difficult. Okay, so it's having, certainly it not happens if we use a more polar solvent, that is possible to elute from the column, but they are having different capacities to get binding at the stationary phase, right? Now, the rate at which solid will move over the stationary phase will depends upon the magnitude of K. Definitely that depends upon the magnitude of K. The rate of movement of solid will be the product of a two term. Rate of movement of a solid will be the product of two term. The rate at which movement of the mobile phase, or the rate at which movement of the mobile phase move, rate at which the mobile phase move, okay, and the fraction of the molecule of the solute present in the mobile phase. So if Fm is the fraction of solute present in the mobile phase, so see, Fm is a molecule of the solute in the mobile phase upon total molecule of the solute. Molecule of the solute in mobile phase upon total molecule of the solute. That is what the Fm. Okay, that is what the fraction of solute in the mobile phase. म्हणजे mobile phase मध्ये किती आहेत upon total molecules. So see, these are what the concentration. This is what the concentration of the solute in the mobile phase, and this is a total concentration. Means total concentration means what? In the mobile phase plus on the stationary phase. Okay, so where Vm and Vs are the volume of stationary mobile phase and stationary phase. Volume of mobile phase and stationary phase. So dividing by CM-VM to the both numerator and the denominator. See here you are dividing here to the numerator and here to the denominator. So that ratio will come. See here this ratio will be 1. So to the numerator it's 1 upon. Sorry, this value will also comes as a 1. So here is a 1 plus K into Vs upon Vm. Now what is a K? What is a K? Is the ratio of Cs upon Cm. From where it come? From here it comes. What the K? Cs upon Cm. So here Cs upon Cm. Okay, that will be the K into Vs upon Vm. Okay, what is Vs? It's a volume of stationary phase. Vm is a volume of mobile phase. Okay, so the volume of stationary and mobile phase will be the constant for a given system. So Fm is equal to 1 upon 1 plus K double dash. K double dash. Okay, so that is the what is the K double dash? It's a product of these two terms now. The product of these two terms. K into volume ratio of stationary phase to the mobile phase. Okay, here it is. The velocity of solute to the moving over the stationary phase will be how it will be given. So velocity of solute that will be the velocity of mobile phase into fraction of solute in the mobile phase upon fraction of solute or the total fraction of solute. Okay, so Vm upon 1 plus K dash. That will be the Vm upon K plus, that is, Fm. They are giving here Fm. So I should say it should be, as they are mentioning here, K double dash. Here it should be the K double dash, okay? Because the value is taken, or that is the Fm value is taken from this equation, okay? Vm is the velocity of mobile phase. The velocity of solute will depends upon which factor? See, the velocity of solute will depends upon velocity of mobile phase, then distribution coefficient of solute between two phase, right? What is the distribution coefficient? That is K. Okay, and then the volume ratio of mobile to the stationary phase, all these factors. See, Vm, then the what is the K? This is a K into Vs upon Vm. So that depends upon this one, this property, this term, and this term. Okay, now the time taken by solute to move over the stationary phase and to come out of the column is defined as the retention time. What is the retention time? Length of a column upon velocity of solute. Okay, this is what the length of column upon velocity of a solute. So as we know that length of a TR equal to L upon V. So L into what he is taking here, 1 plus K double dash upon Vm. Okay, so see, L is as it is. So 1 upon V, for 1 upon V is taking this term. Okay, let me check it out. How it is. V. What is V? Vm into Fm. Okay. Vm into Fm. Then that is equal to Vm upon 1 plus K double dash. So if you take here upon Vm upon 1 plus K double dash, okay, that will be the right. Okay, this is right, no problem. This is taken from here only. Yeah, here it is. Okay, they are taking this equation. Okay, TR is equal to L into 1 plus K double dash upon VM. After that, some retention time is there. What is retention time? It is a time taken by solute to move over the stationary phase and to come out of the column. कॉलम म्हणजे थोडक्यात असं समजा की आपला जसा नळाचा पाईप असतो ना छोटासा तुकडा, समजा 1 फूट आहे 2 फूट आहे ना, नळाचा जो पाईप असतो तसे कॉलम असतात. फक्त काय की त्याचा जो रेडियस आहे तो अगदी आपल्या ब्युरेट सारखा छोटा पण असू शकतो किंवा अगदी 1 इंच 2 इंच अगदी 3 इंच अशा पद्धतीने तो कॉलम त्या ठिकाणी काय असतं त्याची साईज असते. पण लेंथ मात्र फार फार तर की 1 फूट 2 फूट आणि त्यापेक्षा जास्त नाही आहेत कारण ते ग्लास मेड असतात आणि त्यामुळे that is a delicate material and that we are using for the separation. Okay, but we know that L is the length of column and VM is the velocity of a mobile phase. So time taken by mobile phase to move over the length of a column is given as Tm is equal to L upon VM. Okay, L upon VM. So here is a L as it is. Here they are taking VM. Okay, instead of V there is a VM. Okay, and that will TR is equal to TM into 1 plus K. TM into 1 plus K. So they are taking here. So this is I am not confirm about this equation from how they calculated. I need to go through it. Okay, in the next lecture or later on I will make it clear to you the problem. So TM is the time taken by mobile phase to come out of the column. Okay, and the TR is known as the retention time of the solute. As seen from the expression, retention time is depends upon the length of the column and velocity of the mobile phase. Okay, then this also depends upon the distribution coefficient of the solute between two phases and volume ratio of stationary phase and the mobile phase. Volume ratio of stationary phase and mobile phase. Okay, so all these are the factor on which this TR is dependent. Okay, so this is a TM. Okay, and this is a TR. Okay, this is a width W. Okay, this is what our solute. So from here we are injecting the component into the column and that start to get separate out. Okay, so at this time है ना, असं एकदा मोबाईल फेज स्टार्ट झाला बाहेर यायला तो साधारणपणे आपण त्यात टाकला की साधारण असं समजा की 2 मिनिटांमध्ये मोबाईल फेज बाहेर आला, पण सोल्यूट बाहेर येण्यासाठी टाइम लागतोय साधारणपणे त्याला 10 मिनिट 20 मिनिट काय असेल ते त्या ठिकाणी टाइम लागेल. डेफिनेटली मोबाईल फेज अगोदरच बाहेर येईल कारण असं समजा की एखादा कॉलम आहे त्याच्यामध्ये काहीतरी तुम्ही भरलेला आहे तर त्यातून जर पाणी ओतलं तर डेफिनेटली पहिलं पाणी बाहेर येईल आणि नंतर समजा त्याच्यामध्ये काही कचरा असेल है ना, तर तो जर हेवी असेल तर तो नंतर बाहेर येईल पण पाण्याबरोबरच बाहेर येईल. लाईकवाईज है ना, त्या कॉलम मधून जो सोल्यूट बाहेर येतोय दॅट विल कम विथ द मोबाईल फेज बट इट विल टेक सर्टन टाइम. ओके, पण पाणी मात्र असं आहे की समजा पटकन बाहेर येईल त्याला कमी वेळ लागतो म्हणून हा टीएम जो आहे त्याला कमी वेळ लागलेला आहे बाहेर यायला, मात्र सोल्यूटला बाहेर यायला जो आहे टीएम म्हणजे मोबाईल फेजला वेळ कमी लागलाय कॉलम मधून बाहेर येण्यासाठी, मात्र सोल्यूटला त्या कॉलम मधून बाहेर येण्यासाठी वेळ जास्त लागलेला आहे. ओके, नाव retention volume. Retention volume is defined as the volume of a mobile phase required to elute the solute from the column. आता एक त्या कॉलम मध्ये मी तुम्हाला सांगितलं की कॉलम असा आहे की असं समजा की एक पाईप आहे. ओके, आणि ह्या पाईप मधून किंवा थोडक्यात मी तुम्हाला असं सांगेन की तुमचा जो ब्युरेट आहे ना तोच समजा कॉलम, that would be the more easy to understand. ओके, आणि याच्यामध्ये सिलिका भरलेली किंवा चॉक पावडर भरलेली आहे असं समजा सर्व इथपर्यंत आणि वरती ह्या ठिकाणी आणि थोडा ब्लॅक स्पेस आहे. ओके, इथून वरती आहे असं समजा आणि ह्याच्यामध्ये आपण काय करणार आहे जे सोल्यूट सेपरेट जो सॅम्पल आहे ज्याच्यातून सोल्यूट सेपरेट करायचे वेगवेगळे किंवा कंपोनंट सेपरेट करायचे तो याच्यामध्ये पोर केलेला आहे. इथे इथे भरला तो आपण समजा. ओके, या ठिकाणी आपण तो भरलेला आहे त्याच्यातून कंपोनंट सेपरेट करायचे. ओके, आणि याच्यावरती पुन्हा हा स्टेशनरी फेजचा जी पावडर आहे ना ती पुन्हा टाकते मी थोडासा एवढा लेअर देतोय. याचं कारण असं की जे आपण कॉम्पोनंट टाकलेले आहेत ते डिस्टर्ब होऊ नये त्याला आहे ना, कारण मोबाईल फेज वरतून टाकला तर डेफिनेटली त्या ठिकाणी काय होईल, सिस्टम डिस्टर्ब होईल आणि ते डिस्टर्ब होऊ नये हा लेस पर्टिक्युलरली म्हणून मी काय करतो, वरती पुन्हा चॉक पावडर टाकतोय असं समजा आणि वरतून इकडून लिक्विड टाकतोय, जे काही असेल ते, पाणी असेल तर पाणी, मिथॅनॉल, इथॅनॉल जे लिक्विड असतील ते आपण वापरणार आहे ऍज अ मोबाईल फेज है ना. आता इथे गॅस वापरतात ते, दे आर युझिंग गॅस. ओके, सो दॅट्स वाय consider here every time gas as a mobile phase. Okay, so retention volume is a it's a product of retention time into flow rate of mobile phase. Okay, so it's a product of retention time into flow rate of mobile phase. So retention volume, it's Tm into 1 plus K dash into F. So Fm is the flow rate of mobile phase, Tm is the retention time of mobile phase, then the product of two will be the retention volume. Okay, Vm. So that Vm it's a product of these two terms. Here it should be Tm, here it should be Fm. Okay, the product of these two terms is the Vm. Okay, so Vm is the volume of a mobile phase required to move over the stationary phase for the elution of the component. Okay, as seen from the expression, both the retention time and retention volume are dependent upon the experimental conditions like length of column, flow rate, and the velocity of mobile phase, as well as volume ratio of stationary phase. Okay, to the mobile phase, hence to the mobile phase, hence the parameter independent of these experimental factor have to be defined, right? Now, next term is a relative retention. Next term is a relative retention. What is meant by relative retention? It is defined as the ratio of the retention time of the solute to that of the standard added when both of them are measured under the same experimental condition. Okay, relative retention. It is defined as a ratio of retention time. It is defined as the ratio of retention time of the solute to that of the standard added when both of them are measured under same condition or same experimental condition. So what it means? If you want to separate a particular component using a chromatography, in that case what happens, you are adding a standard to that. Okay, आणि मग स्टँडर्डला बाहेर येण्यासाठी कॉलममधून किती वेळ लागतो आणि तुमचा जो ऍक्च्युअल सोल्यूट आहे त्याला कॉलम मधून बाहेर येण्यासाठी किती वेळ लागतो, that we are going to compare. So in a relation with each other, how much time they are taking to come out of the column or to elute out of the column. Elute म्हणजे काय किंवा इल्युशन म्हणजे काय, की एखादा पर्टिक्युलर कॉम्पोनंट आहे तो कॉलम मधून बाहेर येण्यासाठी किंवा बाहेर येण्याची जी प्रोसेस आहे, दॅट प्रोसेस इज कॉल्ड ॲज ए इल्युशन. दॅट प्रोसेस इज कॉल्ड ॲज ए इल्युशन. ओके, प्लीज रिमेंबर दिस टर्म बिकॉज व्हॉट हॅपन मोस्ट ऑफ द टाइम, इल्युशन म्हटलं की हे काय नवीनच वर्ड वाटतं मुलांना आणि they are get confused. So remember here. Okay, now see, in a similar manner, the relative retention can also be defined as the ratio of the retention volume of the solute to that of the retention volume of standard. Retention volume of solute to that of the retention volume of standard when they are measured under the same experimental condition. When they are measured under the same experimental conditions. Okay, so see here, relative retention, Tr minus Tm upon T dash S upon minus Tm. Okay, or you can write here as a Br minus Vm upon Vs minus Tm. Okay, so what is a Tr? It's a retention time. Okay, so what is a Tm? It's a retention time of the that a mobile phase. Okay, oh my, right? So here it is a time required for the solute to come out of the column, and this is a time required for mobile phase to come out of the column. Okay, so these are what the thing over here. In the same way, here it is Vr minus Vm upon Vs minus Vm. Now you should know what is Vr. This is what retention volume of a solute minus this is what the this is what the volume of a mobile phase. This is what the volume of a mobile phase, and this is volume of Vs. It's a Vs minus Vm. So let me check it out. What the term they are indicating here is, it's a volume of okay. This is, we know that this is a volume of mobile phase, but here it is volume. And let me clear this to you. Okay, I will clear this to in the next lecture. No problem. I will continue in the next lecture. I'm going to stop here only. Thank you.